Welcome to the Raw Coding YouTube channel. My name is Anton, and today we're going to be learning about plugin architecture in C#. Plugins and plugin architecture is essentially being able to extend your application while at runtime. So for example, if you have Visual Studio, VS Code, or Writer to edit code, you can have your extensions or plugins to add more functionality to it. If you've ever used WordPress, you know the power of plugins, and perhaps you can take it as far as saying cloud functions, because the cloud is just one big computer. You're taking your code and you're extending the cloud. As always, don't forget, if you're enjoying the video, leave a like and subscribe. That helps out the channel massively. If you have any questions, leave them in the comment section. Don't forget to check out the description. I have a course that is out. If you want to know C# as I do it, I'm sure it will be useful to you. With that, let's go ahead and get started. Here we have three projects. The server, this is the application that we're going to be extending. We then have an endpoint PDK. So usually you would have an SDK, a software development kit. Here, because we're developing plugins, it's a plugin development kit, hence PDK. Let's quickly take a look at this, and we really have super simple two components. plugin endpoint, this is the thing which is going to essentially mark a entry point to a plugin. And then we have a path attribute, because we essentially want to add endpoints to our server. By the way, that is not the only way that you can extend. If you can write a plugin, you can extend your server in any way that you design. Here, the design is specifically, we want to be able to add endpoints to our ASP.NET Core application. So hence the plugin endpoint and the path attribute. These are the only two things that we have here. The endpoint PDK also has a reference to the framework, so we can actually have HTTP context in here, okay? We then have the server, and the server references the plugin development kit. Nothing else in here, and it is pretty much an empty template. Now, to skip some time of me writing out code, here is an example endpoint that we essentially want to add to our server at runtime. The test endpoint has a project reference to endpoint PDK, and if you're developing a plugin, this setting is important, because basically when you're going to build your plugin, it is only going to output the DLL for the individual assembly. It is not going to include the endpoint PDK DLL. If you remove private, it's going to be included in the output artifact and may collide with the one that is included in the server. With all of that, let's go ahead and go to our program CS, and we're going to think about how can we possibly add more endpoints to our application. Perhaps after we start our application, we hold a reference to the app and we do something like map get. And long story short, that is not going to work. As soon as you run your application, you cannot add more endpoints that way. So what we're going to do is we're going to write custom middleware. So use middleware. We will say plugin middleware, create this type, semicolon over here, and because I can't remember all the types that are needed for the middleware, we're going to go to use authentication, go inside of here, the authentication middleware. We're going to copy the request delegate that we need in the constructor. So CTOR, place that over here. This is going to be the next function that is going to be executing. And then we just need to match the signature of this method. So a method that returns a task and accepts an HTTP context. So we grab this function, place it over here, give it a body, and now we have to fill it out. Let's get rid of this use authentication over here. Before we dive straight into loading the plugin, etc., we can play about with this and get a feel for how this is going to work. First of all, let's say that we're going to have some kind of context. It's going to have a request and it's going to have a path. If this path is equal to something like plugin/test, we want to go ahead and, well, write something to the response. So write async, this will be test. We are going to await here. And then whether this has triggered or not, we can basically catch all the scenarios. If we go to context, response, and then there is a has started flag. If the response hasn't started, then we actually want to fall through to the next. So we're going to take next, invoke it, pass the context down in there, and await. So if we hit next, we're going to hit hello world. Let's go ahead and start this up. So opening this .watch. Here we see hello world. If we go to plugin test, and that actually says plug test, we want plugin test. So let me amend this a little bit, plugin. And there we can see test. Now, essentially what we want to do is, instead of hard coding this here, we want to be able to load up this class over here. So what do? We're going to open test endpoint over here. We're going to delete the assemblies just to be sure. And then we're going to build this. So .NET build. This is going to reproduce the artifacts with the latest information. And all we need to do is just have a path to this assembly. The process of installation of a plugin is essentially just taking artifacts and putting them in the correct place in order for it to be loaded. And then perhaps telling the system, go over here and load this stuff up. So let's go ahead and grab the full path. We're going to drop down the terminal. We're going to come back to program CS and we're going to say, here is the path to the full assembly. We can then use assembly load from, and this is going to accept a path. And now we have an assembly object. And from here on out, if you know reflection, you know what you're doing. You can go to assembly, you can get type. Let's say that we're looking after the test endpoint and whatever class I gave it. So an endpoint in the same namespace. This is going to be endpoint. We're then going to have the path information from this endpoint. Get custom attribute. This is going to be path attribute. And by the way, just for clarity, if I open up path attribute, this is the same path attribute that is coming from this endpoint PDK. Okay. To check for nullable, we can place a question mark over here. If path info doesn't equal null, or we can just say method and path equals to that of the context request. So let me scroll down and quickly skip past this part. And there we have it. If path info isn't null and the method and the path are basically equal and we ignore the cases, we want to go ahead, take this endpoint, we want to activate it. So we're going to go to the activator. We're going to create an instance of this type, and this is going to be a plugin endpoint. So our actual endpoint, this we can call it type. So endpoint type, replace it here and here. Then on the individual endpoint, we can execute it and pass the HTTP context into there. Wait, and that should be good. So the application at this point should restart. If I come back over here and actually let me remind myself of the route, it was plug test. So coming back over here, we're going to remove the IN and go to plug test and we get test. If we duplicate this, and I'm just going to go to the root route here, we're still getting hello world. So we've managed to successfully plug in our additional functionality. Now, if we come back and we're at this pluggable endpoint, we change it. We go to rebuild it. We're still pointing to the same DLL. If we come back and we, refresh, essentially it's going to break. If we come back over here and we say, let's reload the app restarts, so it's working again. And again, if we hit the plug test endpoint, we can see the change. So the behavior that we're seeing over here is once we have managed to load an assembly and its types into our application once, it is very hard to load it a second time because there is something around basically being able to identify that DLL is that unique thing, and we cannot load it more than once. So that's basically the nuance. How do we walk around this? What can we do? Well, first of all, we have a special type called an assembly load context. And this type specifically is giving us a scope in which assemblies are loaded. So instead of just having your whole application, this global namespace, this global application, essentially your assembly is like a drop added to this pool and essentially diluted through it, you're putting a little space in there that's saying this is where I'm going to be adding my new assembly, and then you can go ahead and remove it as well. And that is what the assembly load context is. So let's go ahead and create a new assembly load context. In here in the constructor, you're going to see that you can provide a name to it, and then you can mark it as is collectible or not. If you mark it as is collectible, that gives you the ability to actually unload the assemblies that you have loaded. For the name, we're just going to give it the path. And then for is collectible, we're going to say that it is true. Let's say that this is the load context. And now instead of using assembly load from, and by the way, if you go into the load from method, you're going to see that it's actually using an assembly load context internally. It's just not using a separate one. It's using the default one. Coming back to program CS, we can go to the load context, use it, and say load from assembly path. This is still going to give us an assembly. And finally, let's say that we're going to wrap this whole thing in try catch, or more of a try finally. And by the end this whole thing is done, we are going to call unload. And unload behaves slightly weirdly, although also logically, and we're going to talk about this in just a second. Let's remove this space over here and go over the code once more so we understand what it does. We create this scope for where we are going to load up an assembly. So we have this context and we're maintaining a reference to this place where we are going to be loading assemblies. We go ahead, load the assembly. We do exactly the same thing as we were doing before. And then after we've managed to execute it or not, because we already did the loading, we're just going to unload. And by the way, we're doing this for every request. This is not a production ready solution. We are just trying to understand what the heck is actually going on here. With what we currently have, let's go ahead, open up the terminal. It's going to restart. We're going to come back to this endpoint over here. I'm going to refresh and we're still going to see the same extended endpoint. Coming back over here, we're going to go to test endpoint. We're going to change it back to test. We're going to rebuild. We're going to come back and we're going to refresh and we see the signature is incorrect error. The logic behind why it displays the error of the signature is incorrect, I won't be able to explain to you. However, I will be able to tell you why this is happening. The reason this is happening is because in Program CS, when we're calling unload over here, it doesn't actually instantly unload anything. Imagine this. So you are loading assemblies from a file. You are essentially having this compiled C# code. You are bringing it into your own application, and then at some point you're saying unload. What that is going to do is just remove references, and if you're somehow still referencing any of that code, the unloading is not going to happen, and it's actually only going to occur when the garbage collection runs. So unload over here, even though it's a synchronous method, it's more of a like remove markers. The actual unloading is going to happen when the garbage collection is going to run. So if I open a memory profiler and I reattach to the server process over here, and I'm going to force garbage collection, and then I'm going to come back over here and refresh the endpoint, we now see the change. So when you want to actually unload a plugin and reload it, you actually need to force garbage collection and collect the old plugin from memory. If we come back to the code and we take a look at this, we're loading a type from this assembly. If we take this type and we stick it somewhere on the plugin middleware, which outlives the unloading of assembly, the assembly is never going to unload. This is why if you are uninstalling an extension or you're removing a plugin, it's going to ask you, please restart, because perhaps for performance reasons, the main application needs to take the things inside the plugin and dilute it in its essentially global space. So furthermore, what can we do about this? Let's go ahead and first of all create a private static task where we're going to process the HTTP context, so CTX. We're going to take this whole malarkey, place it over here inside this body, so we're working directly with this. Everywhere where we have CTX or context, let's go ahead and replace it, make the function asynchronous, and we're going to call process right over here on the context and await on it. Give it a little bit of space. The first reason for taking out the logic into its own method is because of the stack. We have this endpoint type variable and it's essentially capturing this type. So until we actually exit the method, even though we have unloaded, so if we would try to force garbage collection over here, nothing would happen because the stack is still keeping a reference to this type over here. So before we can actually start garbage collection, we need to do it outside. We need to exit this method to clear all the references from the stack. Something that you need to be aware of also in this situation is you can supply an attribute mark that is basically called method implementation attribute. And in here you can specify things like aggressive inlining, aggressive optimizations, and think about it like this. If the .NET runtime deems it necessary or just, I don't know, feels like or basically decides to, it's going to say there is no method. It's going to take the code that is over here and it's just going to execute it as part of this method. That basically means even if we're going to put the garbage collection logic over here, if we're not going to define this boundary of a method explicitly, we may be holding on to this reference a little bit longer than we intended to. So let's say that method implementation, no inlining. Again, inlining means taking all of the instructions over here and essentially inlining them into this invoke method. Now that we're giving it this guarantee, essentially, we can go to the garbage collector. we can collect. And another thing that we can call is finalizers. Wait for pending finalizers. If you're wondering what a finalizer is, essentially on classes, you will have things like destructors. So something that looks like this without any parameters. And when the object is actually being garbage collected, this is what is going to run. This finalizer is essentially going to get called sometime after the actual garbage collection runs, and it's going to be placed on the finalizer queue where one after another, the objects which are being garbage collected will get their finalizers called one by one. So here we're basically just saying everything that we have marked as garbage collected or that is being garbage collected, wait for all of those finalizers to be called, okay? So we're doing this, we're still flying a little bit blind because we don't have any insurance whether anything has been cleared from memory. One way that we can double check that stuff has actually been unloaded is using a weak reference to the load context. So a strong reference is going to prevent garbage collection, weak reference doesn't, and it just says, is there still an object on the end of this? Let's take the weak reference, return it from this process. We will then have it over here. So assembly load context reference. We can take this and let's say we'll place a for each loop. We'll retry 10 times while I is less than 10 and the reference is alive. We want to go ahead and try garbage collecting. By the end of this, we can go to the console write line and say unloading successful. Always forget that S over there. Take the LC ref and say is alive, and we'll say not. So if it's not alive, it's successful. If it is alive, then it's unsuccessful. With what we have over here, let's come back, wait for the application to restart. Let's double check that everything is working. So we're just going to refresh the endpoint, come back over here, and the unloading is successful. We can take a quick step over here and say what kind of unloading attempt is it, just to satisfy our curiosity. How many times are we forcing garbage collection to run before the stuff actually gets unloaded? There we have it. Let's go ahead and refresh, and looks like 2 times. Again, refresh, and another 2 times. Why does it take 2 times? I don't know. Which generation is it trying to collect? I don't know as well. I don't really care all that much. Again, the loading and unloading of the plugin is going to be slow. It's really the experience of once the plugin is loaded, how well can you use it, and can you actually update the plugin to, well, update the plugin, because updating stuff actually matters. So we're capable of unloading the plugin by the end of it. Let's drop down the terminal over here, go to the test endpoint, add some more changes. We are going to rebuild the application, come back over here, refresh, and the plugin automatically updates. One last thing that I wanted to highlight over here is the point about references again. So we've seen how if we are essentially keeping references to something, the unloading doesn't happen and we actually need to run a garbage collector. So how can you essentially leak a reference so you can prevent your assembly from being unloaded? And the points about this can be very subtle. For example, if we go to the test endpoint and we're going to say, look, we're going to have some kind of JSON string over here, and we're going to use the JSON serializer to serialize some kind of object where we're going to have a message and say, yo, okay? We're going to take the JSON string, that is what we're going to write over here. And if we're smart, we're going to use write as JSON async. We're going to take this object and we're going to put it here, okay? And JSON serializer, you don't even see it. It's not even there, right? This is what you're using, all fine and dandy. Let's go ahead over here, rerun the build, come back to the application, refresh, and everything is working fine, no problem. We come back, we add all of our changes. We rebuild, we come back, we refresh, and the signature is incorrect. If we come back to the application over here, we're gonna see that we've went through all of our attempts and the unloading was unsuccessful. If you didn't know, now you're basically going to know. The JSON serializer from system.text.json, I don't know about the Newtonsoft one. essentially the type that you're trying to serialize, that is going to get cached. So effectively the JSON serializer coming from this global namespace down into your plugin, and if you're utilizing it in your plugin, through your plugin, you're leaking references into the global space. So this is how easy it is to mess this stuff up. My recommendations for plugins, even though it's sometimes not going to be possible, you want those to be pure functions. A pure function is a function without side effects, although this being essentially an internal solution for Microsoft, I haven't looked far enough, but I think through JSON serialization options, you can actually go ahead and disable it. However, this is going to be the end of this video. Thank you very much for watching. Hopefully this gives you a good starting point on how to write a plugin and what to watch out for. Or rather than writing a plugin, essentially utilizing plugin architecture in your C# application. Please note, it's not fully production ready. We've left the loading and unloading of the plugin in the middleware. You want to take it out. There is a class like System File Watcher. You want to watch the plugins folder for changes. If there is a change, emit an event, try to unload, disable usage of the plugin. You know, you basically have to do all that crazy ceremony as you usually do with edge cases, etc. What if you can't unload the plugin? What do you do in that scenario? You know, voice your scenarios and test them. As always, if you enjoyed the video, don't forget to leave a like, subscribe. If you have any questions, leave them in the comment section. If you would like the code for this video as well as my other videos, please come support me on Patreon. I will really appreciate it. A very, very big and special thank you to all of my current Patreon supporters. Your help is very appreciated. Don't forget to check the description for extra documentation that you can use around this topic. As always, thank you for watching and have a good day.